If I apply, this is 100 gram. Hi everyone, welcome back to my channel. Today we are diving into Hooke's law. Now Hooke's law explains to us the relationship between force and extension on materials. Now, before I will go into the statement of Hooke's law, I would like to explain two kinds of material with the behavior of force on them. I would like you to imagine a spring or a rubber band. And also, I would like to imagine a wood or something like this pen I'm holding. Okay, now in the case of a spring or a rubber band, if you stretch a spring, it's going to experience an increase in length as a result of the force of pull you apply to it. The same thing applies to rubber band. If you try to stretch a rubber band, it's going to experience also an increase in length because you are applying force of what? Pull, right? But in the case of this pen, if I try to stretch it, nothing would happen. Rather, I can break it. Okay? Now, the kind of material that regain its original shape and size when the force that caused an increase in length is being removed, they are known as elastic material. So elastic material are material that regain their size or shape when the distorting force is being removed. Now, the ability of a material to regain its original shape and size when the distorted force is removed is known as elasticity. That is what elasticity is all about, is the ability of a material to go back to its original shape and size when the distorted force is being removed. Okay, so I would like you to watch this simple principle that is behind Ohm's law. Okay, now before then, what is Ohm's law? Ohm's law states that provided the elastic limit of an elastic material is not exceeded, the extension E of the elastic material is directly proportional to the force applied. What does that mean? Provided the elastic limit, that is, when you're stretching an elastic material, be it a rubber or a spring, if you keep on stretching it, a point would reach where what will happen? It will now break or it will cut in that case of rubber. That is the elastic limit of that material. So provided that you do not exceed the elastic limit of that material, Hooke's law plays in. That is, when I apply a force on a material, it's going to cause an extension in the length of the material. So if I double the force, what do you think will happen to the extension? The extension too will double. Okay, so let's watch this. This is the position at first. So a bigger force will cause an increase in the length, a more increase than a smaller force. That is what Hooke's law is all about. Okay, this is an elastic material. This is the spring I talk about. Okay, now if I apply a force, that is, if I stretch it on this direction, let's see what will happen. See, an increase in force cause an increase in extension. Where was the extension before? Let's see. This is the original length. So if I apply force in this direction, you see, and is causing an increase in the length of this spring, right? Okay, if I have two springs, the same thing, if I apply force, cause what? An increase in the length of the spring. All right, so let's go to the mathematical expression of Hooke's law. Mathematically, we said F is directly proportional to E, which is the extension. Okay, so we have force now. F, removing our sign of proportionality, is equal to introduce a K equal to Ke, where F is the force applied, where E is the extension caused by the force. So our K now, K is equal to F over E, and our K is known as the stiffness of the material or the force constant, which is having a unit of Newton per meter. So this is the mathematical expression of Hooke's law. Okay,